All right, our webinar is filling up with attendees. Thanks so much for joining us today. We'll get started here in just a minute as we let a few more join in. Okay, it is just past 11, so we'll get started. Welcome to the Hennepin-University Partnership Summer Webinar Series. My name is Sarah Sangren, and I'm a graduate assistant with the HUP, here with HUP Director Kathy Doty as well. The Hennepin-University Partnership represents a strategic alignment between Hennepin County and the University of Minnesota, coordinating partnerships that capture value for both organizations. This includes research around local government policies and practices, working with students, and sharing of academic and practitioner expertise, which is our goal today. This summer, we've been hosting the HUP Summer Webinar Series to provide a forum for county staff and the broader public to learn and ask questions about interesting research and ideas presented by university, faculty, and researchers. And today, we're glad to be broadening both our audience and expertise to include panelists and attendees from the U, local government, and industry. Thanks to technology for making this possible, and thanks to all of you for joining us. A few Zoom reminders. As attendees, your video and audio are not enabled. Please use the chat function, which you can find in a button or on the bottom of the Zoom window, a button on the bottom of the Zoom window. If you need any tech support or have any questions for the HUP team, I'll monitor that throughout. And use the Q&A function to submit questions throughout the presentation, which the panel will address toward the end of our time. This webinar will be recorded and made available publicly as well. Finally, please look for an email tomorrow morning from the HUP with a brief survey for us to gather feedback. And this survey will also include the opportunity to request more information and to share contact to stay in touch with our presenters about this topic. So now I am very excited to introduce Jeff Standish, our moderator today. Jeff is the Industry and Government Liaison at MnDRIVE Environment and an Institute on the Environment Associate at the University of Minnesota. He will introduce our esteemed panel and get us started. Thanks, Jeff, and take it away.
Great. Thanks so much. Big thank you to Sarah, to Kathy, the whole HUP team. Just so you know, I'm looking over here at my slides on my own screen, so don't be distracted by my head going back and forth. So as Sarah said, my name's Jeff Standish. I work for MnDRIVE Environment at the university, and I wanted to take a couple minutes before I introduce the panel to sort of set the stage and the context. Two main things that I wanted to bring to your attention. One is just tell you a little bit more about MnDRIVE Environment for those of you that aren't familiar with our unit. And then secondly, explain a little bit about why we're talking about anaerobic digestion today. So MnDRIVE is an initiative that was started about 6 years ago. It's a partnership between the state legislature and the University of Minnesota. The main purpose is to align areas of research expertise here at the university with emerging industry sectors to collaboratively address grand challenges across the state. MnDRIVE Environment is one of 5 units here at the university. Next slide. Our vision is pretty straightforward in terms of we work towards achieving this vision in 2 different ways. One, we, much like this webinar, bring experts and professionals together to engage each other, collaborate, and ultimately come up with ideas around project proposals. Next slide. The second way that we move towards this vision is by supporting innovative research. We do this through our grants program. There's 2 core opportunities for funding that we offer throughout the year. Our seed grant is our small scale pilot or pilot scale grant. That is meant to fund lab-based work. And our second one is our demonstration grant. That's a larger scale and is meant to allow demonstration or illustration of solutions that can be implemented across the state. Currently, the scope of research that the funding programs we offer support is focused on remediation of contaminated soil, water, or air through biological or chemical means. It's important for me just to quickly mention that while these proposals to any of our grant programs must come from a university faculty member, we strongly encourage external partners, many of whom are in the audience today, to reach out to myself and the MnDRIVE team with ideas on either project ideas for research or event ideas, ways that we can better engage your organization. And specifically, I want to mention that all of our proposals move towards the vision of collaborative research by requiring that there's at least one partner organization that's part of the project team when it's submitted. Next slide, please. So by doing events, engagement events like this webinar, and bringing together researchers and professionals from across the core disciplines of biology, chemistry, and engineering, we support these research ideas, and MnDRIVE over the past 6 years has built a nice track record of impactful work that is spanning the breadth of basic and applied research, as well as generating innovative solutions, some of which are either have been or are moving towards commercialization. So all of this work is for the benefit of the state of Minnesota. Next slide, please. So that's a little bit about MnDRIVE. Now let me focus on today's discussion topic, anaerobic digestion. Many of you, I believe, in the audience are familiar with AD, but just as a quick refresher, I came across what I think is a really nice visual that sort of summarizes all the inputs at the top, the feed, as we refer to them as feedstock, the core technology there in the center, which is our closed system digester, and then the value add benefits and outputs there along the bottom. So you can see there's quite a few things that can either be become a revenue stream or can be a cost diversion internally if you have AD happening at your facility. I think it's pretty safe to say, although during the discussion period at the end, I'd certainly be interested in comments on this, but I think it's safe to say that the science, the core science of anaerobic digestion is not something we need to prove any longer. And we don't plan on spending a whole lot of time on that in this webinar. There are certainly remaining questions about things like optimization of the technology for different feedstocks, blends, for example, or looking at contaminants that are part of the digestate. But the core science is proven, and what we really want to focus on today, and our three panelists will be talking about in their comments, are things like how we transition or set up our infrastructure, the policies and incentives across our state and our country, and ultimately how do we reshape the economy to be more circular and sustainable, to take advantage of this technology and the sustainability and efficiency that it provides in managing, in this case, organic waste. Next slide, please. So just to drive home the point of the potential that exists here for anaerobic digestion, I pulled together some quick data. This all comes from the American Biogas Council. They have a nice website with a lot of information on it, obviously skewed towards biogas production as their main purpose. But you can see from some of the statistics I put, nationally, we have about 2,200 facilities that are operating and currently producing biogas. That's compared with 10,000 facilities in Europe. So we're lagging a bit behind as a country in terms of optimizing our production. And that figure below that shows the light and dark green bars there illustrates in the dark green the operational biogas systems versus the potential biogas systems. And you can see a lot of potential in livestock waste and wastewater treatment facilities. In coordination with that, across our state, I just quickly plotted there on our map which facilities that I was able to identify have anaerobic digestion going across the 4 different categories: landfills, wastewater, farm, and food waste. And those that are plotted are those that are actually using the biogas that's produced from AD for their own value or additional purpose. So what's not plotted in our map are all of the wastewater facilities that are flaring the methane and biogas off and not putting it to an additional value. And it's certainly clear from the American Biogas Council page, and I think this is an area that we can discuss a little bit at the end of the webinar, is what is the potential across our state to develop further anaerobic digestion and hopefully renewable natural gas systems and production capability. There seems to be a ton of potential, and I look forward to hearing what our panelists have to say about that. So let me, without further ado, go to the next slide and just quickly introduce our panelists. We have three esteemed experts from different perspectives of anaerobic digestion and renewable natural gas. Presenting first will be Bo Hu. Dr. Hu is a faculty member here at the university in the Department of Bioproducts and Biosystems Engineering. His expertise covers a number of different topics, including industrial fermentation, bioprocess development, and waste management, which includes anaerobic digestion. And it's kept him busy for over a decade working on AD. And you'll be hearing a little bit about his work historically, and also some of the most recent work that he's been doing with Second Harvest Heartland on anaerobic digestion. Our second presenter will be John Jaimez from Hennepin County. He's an organics and recycling specialist with the county and the Department of Environment and Energy. John's got a long list of accomplishments that he's completed since 2002 when he started with the county, working on all different aspects of organics recycling programs, from outreach and technical assistance to development of new policies and programs, and also exploring organics processing opportunities such as anaerobic digestion. So we'll hear from John about some of the work Hennepin's been doing, and also for those of you that might be considering anaerobic digestion, some of the key considerations to look at when penciling out or scoping out a project like this. Also want to mention John is a proud alum of the Humphrey School of Public Affairs here at the university. And then our final presenter will be Erica Larson. Erica works for CenterPoint Energy, where she's a regulatory analyst and has been digging into renewable natural gas and their efforts there at CenterPoint to develop a broader portfolio of natural gas services. And most recently, she's been intimately involved with some of their regulatory filings and legislative efforts. So before I let Bo get started, I just wanted to mention quickly, as you heard, there'll be a follow-up survey coming to all of the registrants. There will be a number of questions in that survey, which I put in there, where I'm interested in hearing from those of you that might be willing to continue discussions going forward after this webinar. This is serving as sort of a launching point for a broader effort that MnDRIVE Environment is moving forward on behalf of the university to facilitate discussions, explore areas of research, and hopefully develop some collaborative research projects between university researchers and outside partners to really cement the value of anaerobic digestion and identify where more work needs to happen and where barriers can be broken down. So look for that email. And with that, I will turn it over to Bo.
Thank you, Sarah and Jeff, for including me in this panel discussion. So my name is Bo Hu. I'm a professor at the Department of Bioproducts and Biosystems Engineering. And I want to share a few case studies of the anaerobic digestion in Minnesota. So anaerobic digestion is our industrial process, primarily for the organic waste management. So the primary purpose for the anaerobic digestion is to reduce the pollution levels from the organic waste streams by degrading the organic material anaerobically and eventually to generate methane as the final products. So we use anaerobic digestion to reduce the sludge volume, to stabilize the nutrients, And also we can use anaerobic digestion to reduce the odor and control the pathogen level. So if we harvest the biogas and burn it, using an energy, so we can also convert the methane into CO2. By this aspect, we can reduce the greenhouse gas emissions. So next slide. As Jeff mentioned, that anaerobic digestion produce two types of products. The first one is the biogas. So primarily like over 50% is methane. And the rest of it is carbon dioxide and some trace contaminants such as hydrogen sulfide, which is like a safety hazard and also odorous chemical, and ammonia. So if we burn the biogas, so we can obviously we can generate heat. In the same time, we can run a generator to generate electricity. So this is what we call a CHP unit. That's currently most anaerobic digestion setting up. So if they produce the power, we can also upgrade the biogas by removing all the CO2s and contaminants to purify the methane, and then we can inject natural gas grid. This is what we call the renewable natural gas, or we can compress it to produce compressed natural gas. For the digestate, we have the liquid digestate. It's mostly like a water solution with a lot of nutrients, such as nitrogen and phosphorus. We can use as irrigation water. And a solid digestate, mostly fiber. We can use as animal bedding, composite board, and compost it to produce fertilizer. Next slide. So we have, I'll share a couple examples of the different type of anaerobic digesters. The first one is a mostly commonly seen digester. So this farm digester. Mostly, we set up a farm digester in a dairy farm to treat dairy manure. Currently, we have 5 to 7 anaerobic digesters in operation in Minnesota. And the Wisconsin, our neighbor, is leading the nation because they have a lot of large dairy farms. They have 25 digesting operation. So the first example here is a hub-and-shelled farm digester. So this is the one the state spent like $0.30 million to help set up the digester. It's a very simple design, a plug flow design to handle the manure generated from their 700 to 800 cows. This is located in Princeton, around 40 minutes north from the Twin Cities. Next slide. The second type of digester is most common, but we typically don't see it in our daily life. So these are the digesters different industries set up to treat their sludge, their waste, organic waste. So municipal wastewater treatment plant or food processing, corn acid facilities, paper mills, all these industries. The example here I want to share is an anaerobic digester in Blue Lake wastewater treatment plant in Shakopee. So you can literally see these 3 digesters on the Google map. And the fourth one is their sludge storage facility. So each digester is a 1.4 million gallons. The purpose of this digester is to reduce the sludge generated from the wastewater treatment plant. So they can literally cut down over 50% sludge volume to avoid the sludge to be applied to the landfill. They also use the biogas to heat the facilities in the wastewater treatment plant. Next slide. So MnDRIVE initiative funded our collaboration with the Second Harvest, and we are working with them to set up a techno-economic analysis to see whether they can set up an anaerobic digester. Second Harvest Heartland is a food bank. So they recently purchased a site in Brooklyn Park. This site, 40% of food donation they receive is considered waste, not suitable for human consumption. So they have to dispose around 2 to 4 million pounds of food waste every year. And this typically costs them like $200,000 as a tipping fees. So they're working with our research group to see whether they can set up an anaerobic digester to produce energy and fertilizer. Next slide. So I want to make this really brief. We spent 1 year, my students spent 1 year to study different type of anaerobic digestion systems. We compared like solid digesters, liquid digesters, and we eventually came up with this hybrid two-stage digester system. Next slide. With this two-stage design, we can see that the AD is much stable and with much higher biogas production rate. Next slide. So right now we are working to set up a new type of anaerobic digesters so that we can use the microbial electrochemical system approach to remove hydrogen sulfide and CO2 so that the digester can produce higher grade of methane. Next slide. By using slab scale study, we set up a pilot scale study in the parking lot of the Brooklyn Park facility at Second Harvest. So you can see the first stage, we have 100 gallons of digester to deal with the different type of food waste. And then the second digester is a liquid digester. We run 160 gallon scale. And we have a giant gas bag to collect all the biogas generated from these two systems. So next slide. By having the data generated from the pilot scale, so we do an estimation on how the full scale operation of the digester will look like in the Brooklyn Park facility. So this facility will handle roughly 3 million pounds of food waste, and it will generate actual 44.5 therm of heat, and also 1,330 kilowatt hour of electricity. So based on our estimation, it will literally like cover 70% of electricity bill for this giant warehouse facility. Next one. So the final slide, I will give multiple economic scenarios to run this operation. So we have the most optimistic scenario. By having the anaerobic digester, we're going to save the tipping fees, and we're going to generate electricity to save the electricity bill, the heating bill, and also we're going to generate a large amount of fertilizer that we are hoping that we can sell to the local community around their garden. So this will be generating $224,000 as revenue. So by combining all these savings and the revenues and then minus the operational cost, so this digester will generate $345,000 of revenue. And this is based on the estimation of a $1 million capital investment to set up this digester. The second scenario is more neutral. So in this case, they're going to send this digester as a free for the locals to pick up for their garden. And in this case, they're going to generate $0 for their fertilizer. And even by this scenario, they can still generate $121,000 revenue. The final scenario is the most pessimistic scenario, but it's the most realistic one because it is an urban site. Mostly people won't probably pick up the fertilizer. They have to probably rely on the garbage collection company to collect their garbage. And then by spending $50,000 for the garbage collection, they're going to generate $71,000 as revenue. So looking at the neutral scenario, if we remove the tipping fees and the savings, this will be a typical scenario for the farm digester because they're dealing with the manure, so they don't have a tipping fees to save, and they're generally fertilizer for their own use. So looking at this scenario, this is why current anaerobic digester in the farm settings, they're struggling because the electricity and natural gas price is super low in current moment compared to like 10 years ago, 20 years ago, when they signed a 10-year or 20-year contract. So this is where we need to have some approach to boost up this industry and to save all these farm digesters. So this is all for my presentation. Next slide. I will be more than happy to answer any questions you may have.
Thanks, Bo. If you have any questions, please post the questions in either the chat window or the Q&A window. And once all three panelists have a chance to give their formal comments, we will address your questions if they're not addressed online. Thanks, Bo. John, I will hand it over to you.
Good morning, everyone. I'm here today to talk about Hennepin County's interest in AD and the potential it has to improve organics processing infrastructure in the region and how it can help us better manage organics as a resource. Next slide, please. For those of you who aren't familiar with Hennepin County, Minneapolis is the county seat, and we are the most populous county in the state. And subsequently, we generate more trash than any other county in the state, almost 1.5 million tons per year. Next slide, please. In the state of Minnesota, the state delegates solid waste authority to the counties, and the state requires each county to prepare a solid waste management master plan every 6 years. Hennepin County's current plan includes many strategies aimed at 2 overarching goals: recycling 75% of our trash and achieving zero waste to landfills by 2030. Food waste and food soiled paper products such as napkins, tissues, etc. That's what we call organics, and that makes up approximately 30% of our trash. Achieving the 75% recycling and zero waste to landfill goals by 2030 will only be achieved by keeping organics out of the trash and putting them to a better use. Next slide, please. In order to keep organics out of the trash, adequate processing infrastructure is needed. And most of the organics collected in the county are sent to composting sites. This slide just shows an overview of that organics processing infrastructure in the Twin Cities metro area. Most of the organics collected in the county are delivered to the county's transfer station in Brooklyn Park, which is shown by the blue dot right in the center of the map. From there, the organics are shipped to 2 different composting sites in the southern part of the metro, to Shakopee Medwonkaton Sioux Community Site in Shakopee and SET's site in Empire Township. The yellow dots on the maps are sites that are currently permitted for organics composting, but for various reasons, they're not operating right now. So there's actually a fair amount of composting capacity that could come into operation relatively quickly, but for years there's been discussions about it and it hasn't happened. The Vite site up there in the northwest, that is actually physically built out for composting, but ceased operations about 2 years ago. The SKB site is permitted, but it hasn't physically been built out for composting. Next slide, please. As organics diversion increases to meet these goals, and Hennepin County isn't the only county that's trying to increase organics recycling, all of the metro counties are. As the diversion increases, there will be a need to expand and improve organics processing capacity. This chart shows the actual amount of organics diverted in Hennepin County in 2017 and the projected amounts needed to meet the interim and 2030 goals. The line shows the amount of organics diverted, and the bars show the projected available capacity by various organics management methods. The orange portion of the bars is food donation or food rescue. The gray portion represents food to animals. The yellow portion is composting, and the blue portion is the projected AD capacity that might be available. Currently, most of the county's diverted organics is managed by composting, and near term you can see that the composting capacity is adequate. However, the county's commercial organics requirements began January 1st of this year, and our residential organics requirements will begin in 2022, which should result in substantially higher organics diversion. For food to people and food to animals programs, you can see in the chart that we don't anticipate any significant growth in the next 10 years. And capacity for composting is expected to grow. However, if we rely only on increased composting capacity shown again by those yellow portions of the bars, we anticipate that we may have a shortfall by 2023. And keep in mind, this only shows the Hennepin County situation. Other counties in the metro area are increasing their efforts to divert organics. And when you add those to the mix, there's a good chance that we will hit that the composting capacity shortfall sooner than 2023. Therefore, Hennepin County has been pursuing AD to try to ensure adequate long-term processing capacity. Next slide, please. AD provides an opportunity to expand and diversify our local organics processing infrastructure. It's an opportunity to guard against an uncertain timeline for increased composting capacity, and it puts organics to a better, higher use by also producing clean, renewable energy from the organic materials. Next slide, please. To get the ball rolling on AD, the county released a request for qualifications in the summer of 2018. And what we sought were qualified, experienced, and financially capable entities to develop a facility that could digest a minimum of 25,000 tons per year of source separated organics. We were pleasantly surprised to get 15 responses from a wide variety of AD developers, and we conducted follow-up with the 6 strongest respondents. Within that group, the estimated total facility costs ranged from $14 to almost $45 million, and the estimated tipping fees ranged from $25 to $130 per ton. Next slide, please. In recent years, there has been a lot of focus on evaluating the technical feasibility of AD to process organics. And as Jeff said earlier, Hennepin County also believes that plenty of that work has been done, and it's our opinion that the technical feasibility has been well demonstrated. Really, the key is, what does it take to get these facilities developed, and how do you make them pencil out? That's really the key. I think also, as Jeff said, sure, there are different ways that you can tweak systems. There are wet systems, dry systems, plug flow, batch, all these different things. And for your particular situation, there are different configurations that could optimize what you're trying to process. But overall, in our opinion, there's really no question about that these systems can effectively process organic materials. What we've learned is that the most critical facility development factors are a site for the facility, long-term feedstock commitment, a good financing plan, and also agreements to purchase the products that are produced from these facilities. Near term, the most urgent needs are a site and feedstock commitment. And from that group of 6 that I mentioned earlier in terms of a site, those respondents were seeking a site somewhere between 2 to 10 acres in size, depends on all of the different process steps that would be included on that site, and a long-term feedstock commitment that ranged somewhere between 12,000 to 40,000 tons per year. Until the pandemic hit, we were making progress on both of these factors, but now these efforts have been indefinitely paused. Next slide, please. So for those of you who are involved in managing organics or involved in waste policy, energy policy, or developing AD, I just have some closing thoughts about the state of organics in Minnesota. State law requires metro counties to achieve a 75% recycling goal by 2030. And as I mentioned earlier, recycling organics is really the only path forward to achieve that really tough goal. A key limiting factor, as I showed in the bar chart, is available processing capacity, and AD is well placed to fill that void. Digesting organics from a climate perspective prevents methane emissions and produces clean renewable energy. So not only are you able to process the waste, you still get a soil amendment out of the process, but you also get these great climate protection benefits. And hundreds of thousands of tons of feedstock are still going into people's trash and are available and untapped. To get AD to accelerate development, to really support development, we need strong incentives in place, such as incentives for renewable natural gas. And from a climate perspective, these types of incentives could become the best tools available for greatly reducing the carbon intensity of organic materials of all kinds, including food waste, manure, biosolids, and others. So we see that AD just has tremendous potential going forward in the future. And with that, I'll hand it over to Erica.
Thanks. Waiting for my presentation to come up. I'm Erica Larson. I'm a regulatory analyst at, there you go, CenterPoint Energy. Thank you for having me today to talk a little bit about how we're looking to bring renewable natural gas onto our system and start using it to bring down our carbon emissions. Next slide. So first, just a little bit about CenterPoint Energy. We're a big energy company. We have electric and natural gas distribution. We're not entirely unique among energy companies in this way, but we are a little bit different than many of the others in that we are primarily a gas company when we're talking about our carbon emissions rather than an electric generation company. We only have electric generation actually in a little bit of Indiana. So when we're looking at a company about what we can do to respond to climate change, our problem is squarely a problem of gas distribution, which is a little different than many energy companies, which are very focused on, retiring coal plants and that sort of thing. Next slide. Who we are in Minnesota. We are by far the largest gas utility in the state, serve a big chunk of the southern part of the state. Our largest city is in Minneapolis. If you live in St. Paul, you have the misfortune of being served by Excel Gas. No, they're fine. They're great. But we're a big part of the gas distribution in the state. And so in terms of the state meeting its climate goals, we're an important part of that. Next slide. This is a vision slide. I want to make sure everyone knows there isn't actual data behind this, but this is how we're thinking about renewable natural gas and decarbonization generally in Minnesota. We do not think there is a silver bullet to bringing down carbon emissions from the distribution of natural gas. We think we're going to have to pursue a lot of different strategies. One of those strategies, a very important one, is renewable natural gas, which we're talking about here today. Next slide. So what is renewable natural gas? It's been mentioned by the previous two panelists, but just I want to make sure we're completely clear. Biogas is what is produced by an anaerobic digester, and that has methane in it, but also carbon dioxide, oxygen, a lot of other things. To make that into renewable natural gas, you need to get it to the point where it's interchangeable with gas already in the pipeline, the fossil natural gas. Mostly that means getting out a lot of carbon dioxide, so you have a pure methane product. It also means washing out to some of those constituents that appear in smaller amounts but can be really dangerous to the gas system or to customer appliances. Next slide. So where are we with renewable natural gas? I wanted to give an overview of what are the existing uses for biogas and where it looks like things are heading. So most biogas operations today that are producing some form of energy are either producing electricity. That doesn't require refining it to the point of renewable natural gas. You can just burn the biogas to produce electricity. Alternatively, you can upgrade to renewable natural gas and put it into the pipeline system. Most of the projects that are doing this right now are doing it for the purpose of putting it into natural gas vehicles because of incentives we have in some states and on the federal level to bring down emissions from vehicles. So a lot of the gas right now is going to California because they have really strong state incentives to bring down emissions there. There's also the federal renewable fuel standard, mostly known for ethanol, but is also encouraging the use of renewable natural gas. An emerging use, one that CenterPoint Energy is obviously very interested in, is using that renewable natural gas that's going into the pipelines in homes and businesses rather than in vehicles. Some challenges to this use are, first, conventional natural gas prices are very low. So, even if you're a very sustainability, even if you have a lot of sustainability commitments in mind as a company or a homeowner, it's a big price difference. Another challenge is that there's essentially no state or federal support for using renewable natural gas this way. That's changing, and a few states have started taking action in this direction, but it's still pretty nascent. Next slide. So what is CenterPoint Energy doing? Well, the first thing we tried was a green tariff proposal. If you're familiar, on the electric side, they offer, they're called green tariffs, where a customer can volunteer to pay extra to get their energy from wind or from solar. We wanted to offer the same thing to our customers. We took this idea to our Public Utilities Commission. I think it was a very new concept to them and to all of the stakeholders involved. They were friendly to the idea. They were interested in us coming back with a new proposal, but they weren't quite ready to give us the approval to move forward yet. They gave us a variety of conditions that they wanted us, these 3 conditions I put up here, that they want us to talk about more in our next proposal. The hard one for us is the local supply. They'd really like to see Minnesota RNG. And right now there are no projects creating RNG and putting it into the pipeline system in Minnesota. There's one under construction, but none yet. Next slide. To help maybe bring about some local supply, we have now filed a proposal to allow interconnection directly to our system. And the hope here is that by opening up our pipes to renewable natural gas, we'll encourage development of RNG in the state. This wouldn't be for us to buy the gas, since we don't have authority to do that yet. We don't have authority to pay extra for RNG as opposed to fossil gas. But this would give projects access to markets where folks are willing to pay extra. So specifically California for use in vehicles, it would let folks get there. So in this proposal, we're proposing rates for the service of transporting the gas, and also importantly, gas quality standards to make sure that the RNG entering our system is safe for our customers as part of the supply. Next slide. So those are sort of our 2 regulatory efforts that we think we can undertake without legislation. But I think long-term, in order to continue moving forward in this space, we are going to need legislative action. So to that end, this spring, we had a bill that we were supporting called the Natural Gas Innovation Act. It did a lot of things to say that, gas utilities, the legislature encourages us to bring down our carbon emissions. There was a study to look at how much RNG is in the state. And then the heart of the bill was alternative resource plans, which I'll talk about more in a second. The bill did, in some ways, very well, better than I had dared to hope at the beginning. We were passed by the Senate by a wide bipartisan margin. Unfortunately, we were not able to get a committee hearing in the House, so we did not move forward in the House. Next slide. So the alternative resource plans that I said I would talk about, the heart of the bill. The idea here is that, like I mentioned on the first slide, there's no silver bullet to bringing down emissions from natural gas. So we need to be trying out a lot of different things, including bringing renewable natural gas onto our system. So we proposed a framework to bring ideas to the Public Utilities Commission, gave them criteria to look at, and we're going to invite all of the stakeholders to come in and critique and weigh in and disagree with our ideas, so that hopefully we could come out at the end of the day with a portfolio of pilot projects to begin some of these ideas, capped at a cost so that our customers wouldn't bear too much in this effort. So hopefully someday we'll get to do something like this. Next slide. The last thing that I wanted to talk about was sort of I think really the heart of the effort has actually been about building a community of stakeholders. And we're certainly not the only folks working to do this in the state, but I think we are part of this effort to really deal with the problems of how do we handle waste and also what are we going to do about these emissions from the natural gas grid? Both very difficult problems that are intersecting. So I just wanted to point out how many folks are involved in thinking through these problems and how many different angles we have here. And thank you for your listening to me. I'm happy to take questions.
Thanks, Erica. Thanks, John, and thanks, Bo. Some really interesting comments and presentations. Yeah, Erica, I really appreciate you ending with that slide showing all the different organizations and people that are working on this. Hopefully, I didn't mean to come across at the beginning as saying that this is something that necessarily the university is unique in doing and talking about. We just want to work collaboratively with everybody. So certainly hope to hear from members of the audience. At this point, we've got a number of questions that have been submitted, and I can encourage you to continue submitting the questions in the Q&A window. Why don't we try to get a few of them answered live here from our panelists. Let's see, I'll go up to the top of the list. Question for John. What is the permitting process in Hennepin County or the state of Minnesota for building AD facilities? How long does it take? Do you anticipate any public pushback from communities and residents? You're muted, John.
I had to do that at least once. The approval process would occur at the local level and the state level. So for those of you who don't know this, the county can't just cite any kind of facility or use on a parcel of land without local approval. So in terms of zoning, we would have to get approval from whatever city the site was cited in. And then at the state level, it would really depend on the exact configuration of the facility. So they would be looking at potential air emissions from the facility. If it was a wet digester that was generating a lot of wastewater, they would be looking at the wastewater discharge. And then it would probably also be permitted as a solid waste management facility, depending on how many tons of solid waste were coming into the facility. One of the primary concerns that the state has raised about AD is exactly what happens with the digestate. So a facility that recycles material, one of the advantages of for a generator of waste, if they recycle material, is that all of the costs related to that being collected and processed are tax exempt, but only a certain amount of residue of non-recyclable things can be received at that facility, and then the final product has to be used in a certain way. So if you were taking in really dirty material and the digestate was really dirty and couldn't necessarily be used as a soil amendment, then there would be a question as to, whether recycling was really happening at that facility, or is it just an energy production facility? So it'd be a little bit complicated on the state side. We anticipate at least a year. We've been in discussion with the Minnesota Pollution Control Agency about permitting, and it's actually an ongoing discussion of trying to get more predictability up front in terms of what they would need to know so that we could expedite that permitting process. But at least a year, possibly longer.
Great. Thanks, John. A couple questions for Erica. One, I think you can probably pretty quickly answer. Why didn't the bill get a hearing in the Minnesota House? And follow on to that, is the Natural Gas Innovation Act a Minnesota bill or a federal bill?
Sure. So it's a Minnesota bill. So it was in the Minnesota Senate and the State House. The bill did not get a hearing in the House because we were unable to convince the chair of the Energy Committee to hear it. I think there are a lot of reasons in there, but I think that she wanted to see really, really big solutions to problems. She wanted us to have a goal of 100% reduction of carbon emissions And we were more the perspective that there are things we need to try out, and also the Senate's never going to pass a bill that has us aiming for 100% reduction in carbon emissions. So it sort of was a victim of politics. And of course, COVID and the things that happened towards the end of the session did not help.
Great, thanks. Here's an important question. What is the difference in the carbon footprint of biogas versus RNG, or biogas and RNG versus fossil methane? Who wants to address that?
I could take the first shot at it.
Sure.
So it's a rather complicated answer. It really depends on how that biogas is produced, and then what it takes to get it to the point of use. So this is a critical part of the California program, and would probably be a critical part of a Minnesota program if it goes forward. The low carbon fuel standard program in California, in order to get your facility to qualify for that, there's a carbon intensity study that's done, and it looks at all of those different pieces of, what is the feedstock, what type of digestion is being done, how far do you have to transport it to get it to the injection point, and then how is it used ultimately? Is it used as a vehicle fuel? Is it used for some other purpose? All of those factors are taken into account, and you get a carbon intensity score. Usually, for example, I'm focused on food waste. So if biogas is used for a vehicle fuel to replace diesel, and the way it's produced doesn't take a whole lot of energy, I mean, it can be massively carbon negative. It's about the most carbon negative score that you can get. But also something like biogas from a landfill is somewhat carbon positive, but not as much as a lot of other things. So there's really a wide range.
Yeah, I don't know if either of you have anything else to add quickly.
Oh, I've seen from the World Resources Institute looking at the fuel that's going into California, the RNG tends to be between 40% and more than 100% less carbon intensive than the gasoline that would be used. So that can give you an idea of the difference.
Yeah. And I just add a quick mention that Xcel Energy has, I think, open till the end of this week, a request for information, as they're also developing renewable natural gas portfolio. And one of the research questions that I've been talking with some of their people about is exactly this: the sort of carbon footprint and the tracking and detection of methane, and then how it's modeled for the carbon reporting on a facility basis. So good question, and definitely an area of research that I think we'll be, as a community, diving into much more deeply. Let's continue on with some questions here. Question about digestate. Do you know what the NPK values are for the digestate? And I don't know what NPK stands for, so please clarify what that is.
Oh, I don't have a specific number in front of me. So N stands for nitrogen, P stands for phosphorus, and K stands for potassium. So these are the common fertilizer components. But it really depends on the what kind of feedstock we get in the anaerobic digester. So during the anaerobic digestion process, we may lose a little bit nitrogen because we're going to have a little bit of ammonia production. But mostly for NPK value, they're going to stay as it is during the digestion. The form might be changed a little bit. So, the phosphate, maybe it's from organic phosphate into more like inorganic phosphate during the anaerobic degradation. But the content should be pretty much the same.
Okay, great. And a follow-up question on that, that Bo, you can probably address was, are there any issues from chemicals of emerging concern that are in the digestate and potentially going to be used for fertilizer?
Oh yeah, this is a good question. We had a discussion within our panelists a couple of days ago when we prepared this presentation. So, you know, if it's like a landfill site, it really depends on what kind of a raw material we are using for the anaerobic digestion. So if we are collecting the biogas from a landfill site, so, you know, there will be some sort of contaminants in the biogas itself. So that's something we need to be aware of. You know, if the raw material contains like PFAS or, you know, those kind of emerging contaminants, this will be shown up in the biogas or in the digester for sure. Yeah, this is an interesting topic.
John, do you have anything you want to add?
I would add that, add to what Bo said specifically about the PFAS. So the PFAS, you know, that's an emerging issue that, I mean, it cuts across many sectors. It's the same concern that would apply to digestate would also apply to compost. And quite frankly, PFAS is found everywhere. PFAS is in the food that ends up going to the composting sites and would go to the digesters. So there's a big question about how, you know, how exactly is PFAS going to be regulated going forward? And there's no clear path to go forward. So, you know, we have to assume that we're hoping the regulation will be reasonable. And if it's going to apply to digestate, it's also going to apply to composting. And we have to do something with this material. So we're keeping engaged and crossing our fingers.
Yeah, and I would just add that John and I have been part of an ongoing discussion with another group, some of which I think are in the audience in this webinar itself, focused on research related to PFAS, how to identify where it's coming from, how to remediate it, potentially with some novel microbial or other means. So that is definitely an area of research that we'll continue to discuss and move forward on.
And if I could add one final piece to that,
Sure.
I didn't go into detail on one of my slides about why AD is preferential in a lot of ways to composting. One of them is specifically related to that issue because of the way the feds and the state are regulating PFAS really relates to stormwater, and when that stormwater comes into contact with the food waste material, and then how is it managed on site. The greatest concern about the PFAS at that point is getting into the groundwater. And again, it's so unclear how strict the regulation is going to be and how much that's going to increase the cost of composting. Where at an enclosed AD facility, it's much easier to deal with the stormwater issue and to keep that stormwater from coming into contact with the food waste. So that is one of the primary benefits of AD.
Yeah, it's a great point. Thanks for mentioning that. And I'll also add, I just got a quick message from Tim Goodman. Thanks, Tim. He says the food service packaging industry is working on solutions for PFAS and will likely have alternatives soon. We'll keep our fingers crossed for sure. It should also be pointed out that PLA-based products do not contain PFAS. So thanks for that comment, Tim. We are at 11:59. I'm sure if I didn't mention this, Sarah would probably jump on and mention it. We're going to continue answering questions for a few minutes, but if you need to leave at the end of the hour, feel free. We will try to get through as many questions as we can over the next, I don't know, Sarah, what, 5 minutes, 10 minutes? Okay. So I'll continue in the list here. From Scott, he says, from what I understand, composting and biogas from anaerobic digestion is market driven. Do you think it would benefit from being regulated as a utility? Erica, that sounds like it's right in your wheelhouse.
Sure. So there is a little bit of we make a joke. So the electric utilities are often vertically integrated if they own the generation distribution. There's no such thing as a vertically integrated gas utility. We don't own our there's no generation. We just buy it from someone who's getting it out of the ground. So we joke sometimes about being vertically integrated, but we think for now at least it probably doesn't make sense for us to be producing RNG. There are a lot of people who are a lot better at it and have lots of expertise in developing these facilities. You know, I think at least for the foreseeable future, CenterPoint is not thinking about getting into that business in any sort of regulated way. But we are just hoping to be able to purchase the RNG from those producers, so those non-regulated producers. Whether it would be better to take it away from the market, I don't really think it's market driven right now, because the cheapest thing you can do is buy conventional natural gas. So the things that are driving production of RNG are those are credits, either using the biogas to generate electricity to create renewable energy credits, or for those vehicle fuel market credits. That's what's driving the production. So it's not just a straight market force. And I definitely think there's a role for government and regulators to play in encouraging the production of RNG, encouraging us to buy RNG as a utility.
Yeah, great. Thanks, Erica. Let's see, question for Bo. Could you please elaborate a little bit more on how electrochemical H2S removal works?
So we are using the microbial electrochemical system to precipitate the hydrogen sulfide generated from the anaerobic degradation process. So this, you know, it's kind of a system. We install like 2 electrodes. The electrode is made of a low carbon steel. We apply very low voltage to the system, and by sacrificing the electrodes, we're going to precipitate any sulfide species that generate during the anaerobic digestion process. So by doing this, we're going to not produce any hydrogen sulfide during the AD. So our paper will be published soon. We recently just finished the revision, and you know, if you're interested, I can send you our paper to read.
And we can also get that posted on the MnDRIVE environment website, Bo, for people to access.
Sure.
Couple more quick questions here. Actually, a resource mentioned by Tim Farnott. Thank you, Tim. He pointed to, I think it's a 2018 report by Great Plains Institute, which is certainly one of the organizations that has been very active in this discussion and area. It is, looks like provides a high-level overview of key AD permitting considerations. So I think if you just Google Great Plains Institute anaerobic digestion, it'll probably pop up pretty quickly. And I can share the link in the follow-up email if people are interested. Let's see, a couple questions from Virginia Black. Let's see, food processing facilities have a very clean food waste stream. Curbside collected food waste has significant contaminants, making it difficult to process both by composters and AD facilities. Maybe John, you can briefly address that, because I believe Hennepin County has curbside organics recycling. Is that correct?
Yes, we do.
And I think Ramsey, Washington County are considering it soon.
Correct. So the from the waste composition studies that we have done with some of the cities with curbside programs in Hennepin County, that material is actually some of the cleanest material. One of the reasons is because those are opt-in programs, so only people who want to participate choose to participate in those programs, and those have been amazingly clean. It's actually some of the commercial organics that is the most contaminated, especially from the hospitality sector, restaurants, hotels, event centers, etc. One of the yet another advantage of AD is that the pre-processing systems that typically are part of an AD system have the ability to remove almost all of the contamination. Several of the sites that I've visited have usually a 2-stage pre-processing system that removes plastics, metal, glass, grit, and cleans it up to a point where the digestate is very clean. A composting site, you could possibly use those pre-processing systems at a composting site. The difficulty is those systems produce essentially a slurry, and those slurries aren't necessarily handled well in a composting process. We're looking at possibly working on pre-processing at our transfer station before we send material to a composting site, and we're in discussion with the composters. But from what I've seen so far, those systems are much more effective when they're coupled with AD.
Great. Let's take one more question and then we'll wrap things up. Bill Lazarus asks, what information is publicly available about the economies of scale in biogas upgrading to natural gas standards? Not sure who wants to take that. Maybe Bo, you want to start?
Oh, I actually don't have this information. Erica, do you know this?
Yeah, I don't think there's a great, I can't point you at a study that I think definitively answers the question. I think there's a lot more research that needs to be done about sort of how we use biogas and where it makes sense to upgrade to RNG versus use for electricity generation. So I think that, there's a lot of discussion right now about whether renewable natural gas facilities make sense for smaller projects and at what size they make sense. Certainly the ones that are being developed right now tend to be, like large dairy projects. Those are the ones that are really getting snapped up because they have clear economies of scale. Payback is very quick. There's a lot of regulatory uncertainty about the vehicle fuel credits right now, so it's important for these projects to have, payback within just a few years or they can't get financing. And also they have, because they're dairy projects, they have a really low carbon intensity. They market well in California. And I think there is a problem in that those are really the only projects we're incenting right now, or at least incenting to that degree. So I would encourage folks to do that research, please, or let me know if I'm missing a study. I'd love to see it.
If I can add to that too, I mean, one of the main reasons why those dairy projects are scoring so high are so low on the carbon intensity scores is because essentially they've just had to open lagoons up to this point. So one of the key improvements that happen is when they cover that lagoon, they eliminate all the fugitive methane emissions. So it isn't necessarily coming from the RNG side of it, it's from fixing, these lagoons that have just been releasing methane uncontrolled for years and years and years.
Yeah. That's a really good point. Thanks both for that. And I'll just add to that, I'm really excited. Yesterday I was on a webinar. The Institute on the Environment here at the university just funded a bunch of impact goal projects. And one of them is a collaboration between the Carlson School of Business and INE researchers looking at how green bonds might play a role in financing some of this work, whether it's anaerobic digestion or other sustainability projects. So I'm looking forward to seeing how that project plays out. But indeed, there is, I think what we've been able to communicate in this webinar is a clear potential for development of biogas and anaerobic digestion systems. I'll point to St. Cloud wastewater facility. Bo looked at the Blue Hills one locally, but St. Cloud is actually, upon conversation with them, they've been, they're actually trying to develop a second digester unit right now because they have so much feedstock coming their way. They need a second digester to handle it. So they've been offsetting a large proportion of their costs in electricity and heating. And so they're, I think, maybe going out on a limb here, maybe a potential site for RNG development as well. So look forward to...
I don't think that's on a limb. They are, sorry, they're
okay.
very interested.
Well, thanks. So thanks all for joining today's discussion. As I said, there'll be a survey coming out tomorrow. I certainly hope to hear from a number of you on your interest in continuing these conversations, specifically in areas of interest that fit with your organization. I want to thank the three panelists, Erica, Bo, and John. This has been a great discussion, and they certainly have shown interest and mentioned to me that they'd like to stay in the conversations going forward. So I want to thank them again and thank all of you, and thanks Sarah for the logistics on this end.
Can I add one shameless plug?
Sure.
So the report that Tim Farnan referenced by the Great Plains Institute was commissioned by the Partnership on Waste and Energy, which is a joint powers group of Hennepin County, Ramsey County, and Washington County. And the partnership is very interested in AD. And we are currently working with the Great Plains Institute on a second report looking at policy recommendations for moving AD forward in the metro area and in the state. So for those of you who are interested, we're hoping to have that completed by the end of the year. So stay tuned for that.
Great, we can include that, a link to that report in the email that'll be coming to all of our attendees tomorrow morning, if that would be useful. Yeah, thanks again to everybody who joined us, and thanks so much to Jeff, Erica, Bo, and John for working with us to get this going.
Thanks all. Have a great day.
Thank you.
Bye.